Welcome to Terrible Lizards, a podcast about dinosaurs with Dr. David Hone and Izzy Lawrence. In this episode, we find out why the Triceratops got its frill, and our guest, Ralph Attanasia, asks a cheeky question. Hello and welcome to Terrible Lizards. Now, as usual, we begin every single episode now with a correction from last week. So here is Dave, here to make his correction.
Not every single episode, but yeah, it's somewhat inevitable. If you're going to talk for an hour unrehearsed, you're going to say something that isn't quite right.
We should, perfection. We need perfection.
Yes. I'm sure I've said a few things that aren't quite right, but this is one that's wrong enough that after I said it, I went, oh yeah, I'm not sure that's right. I better check that. So we talked about the dinosaur renaissance in the 1980s, which is definitely still a thing. But I'd said that the work that was the kind of the springboard of that was the discovery and description of this amazing dinosaur Deinonychus by John Ostrom. And I think I said that happened in the late 70s. And Ostrom's description of Deinonychus came out in 1969. So he must have found it a while before then. So I stuck an extra decade on, or delayed his research by 10 or 12 years, which I really didn't mean to.
To be fair, if you could date most of your fossils within a decade, that'd be amazing. So I think, you got the right century. I think that's pretty good, considering you're a paleontologist.
Out of 65 million years, yes, 10 to 15 years accuracy is fantastic. And no one should criticise anything that I say as a result.
Fair enough. What I want to talk about this week, though, is the coolest of all the coat stands of the dinosaur kingdom, which is the Triceratops.
Yay!
Things I know about Triceratops are that it was definitely around when it was fighting T-Rexes, because that is in everything, and that's about it. So, can you tell me about the Triceratops?
I can. So, yeah, Triceratops is coming from the very end of the Cretaceous, so the last few million years of the dinosaurs. And yes, is from North America, Western North America, and therefore found right alongside T-Rex. We literally have Triceratops bones with T-Rex tooth marks on them. These things are sympatric is the correct term, so they live in the same time and at the same place.
Sympatric? Are we sympatric
yes.
then?
Yes, effectively.
Boom.
But you can talk about things that are living in the same place but at different times, or living at the same time in different places, and this means that they literally overlapped in time and space. So, there's lots of dinosaurs that are scattered around the globe. We have all kinds of odd little bits, and often we have only one or two skeletons or bits from a single, geological point. And of course, that fauna is almost certainly not two species. That's just all we have. And with the various gaps, there's lots of things which we're pretty sure overlap, but we can't exactly prove it because we just don't have enough data. But this is one where, we can absolutely 100% say that the two things are right on top of each other. Triceratops has three horns. That's the other thing everyone knows about it. Well, Triceratops basically means three-horned face.
Three-horned face. Can we please call it three-horned face from now on? That's amazing.
No, because that's too many syllables. And he's got a little spike on his nose, and he's got a pair of big, what are called brow horns, so one basically over each eye. And then there's a huge frill of bone expands off the back of the head and kind of hangs over the neck. It's a big, fat quadruped. Triceratops is basically the biggest of the Ceratopsians. So the Ceratopsians, as you may imagine, are what we call the horned dinosaurs. Triceratops is the biggest of that. And I think people have a real misconception of just how big it is.
So I think people think it's a rhino, don't they? They sort of think rhino size.
Yeah, rhino plus. And that's because actually most of the specimens that you see in museums are about that size. Again, for people in the UK, the specimen at the Natural History Museum is the one I grew up with. There's an original skull of Triceratops in Birmingham at the think tank, which is quite a bit bigger, but not a whole skeleton. And there's Triceratops all around the world in various museums. And they're mostly kind of rhino to small elephant size. And Triceratops gets way bigger than that. There's a giant specimen, I think it's in Utah, and my PhD student, he's graduated now, he saw it and he said he could fit his head inside its eye socket. That is not an animal that is rhino size. It's an absolute monster. And the big brown horns on those things are like a meter and a half long. And of course, you can then add some horny sheath to that. So you're talking about getting on for 2 meters.
So what's its shoulder height then?
Of the really big ones, probably 6 foot. or 2 meters.
Wow.
Which is a lot bigger than, and...
So that's just above my head height would be...
Well, and they're kind of higher at the hips than they are at the shoulders as well. So
okay.
Bum sticking up a bit on top of that. And they're very solidly built. They're very broad animals as well. And then you've got the tail, which is big and thick and muscular. We talked a couple of weeks ago about Diplodocus and how the sauropods and the theropods have these hollow pneumatic bones. So they're actually rather lighter than you'd expect for their size. Triceratops is one of that other group, the Ornithischians, that don't have that at all. So this is a solid animal. It is every bit as heavy as you would expect for an animal that massive.
And why is it got its back legs higher than its front legs? Because if you look at bulls and that sort of thing, they seem to have very big, broad shoulders.
Yeah, most quadrupedal animals usually have similarly lengthed fore and hind limbs, or at least the upright ones. Lizards are often quite different, but then their legs go sideways rather than down. And a few dinosaurs don't do that. So Stegosaurus is particularly anomalous in that regard. The Stegosaurs have really short little front legs and giant back legs. The Ceratopsians are going down that route a bit as well, probably at least partly because their ancestors, well, indeed, the early Ceratopsians were bipeds. So
really?
a number of groups of dinosaurs. So the ancestral dinosaur that we understand being like the origin of all dinosaurs looked like basically a small theropod. It was a little upright biped with some fairly sharp carnivorous teeth and little clawed hands. And one thing that the dinosaurs did repeatedly is evolve to be quadrupeds from bipedal ancestors. And yeah, the earliest of the Ceratopsians, they're tiny little things, a metre long or so, with a tail, running around on their back legs. They were probably okay on all fours.
I just can't imagine a little Triceratops. I know they wouldn't have looked like Triceratops, but that's what I'm imagining, a sort of kangaroo Triceratops half-breed in my head at the moment, which is wrong.
Yeah, so these little ones, they didn't have horns yet, so they didn't have the spikes on the nose or the eyes, but they did have 2 other features which we see in all of the later Ceratopsians. So they had kind of spiky cheeks. They had little cheek spikes, which in some Ceratopsians get really quite big and exaggerated. And they had the frill at the back of the head. But the earliest ones, this is tiny. Even on an animal with a skull 15, 20 centimetres, it's 2 or 3 centimetres. It's a little shelf that protrudes off the back of the head. And then, fast forward 20, 30 million years, and suddenly these animals are 5 meters long or so, with a big frill off the back of the head and big horns on the nose and the eyes, and are now standing on 4 limbs and are basically fully quadrupedal. And any vestige of being able to get onto back leg, they can probably rear up a bit, but they're not like they're transitioning between the two or anything. These are full quadrupeds at this point.
From my perspective, just anatomically looking at their skeletons, how can you tell that they were definitely not walking upright? One
of the main ways is we can basically look at the distribution of the mass. So, animals that are fully bipedal will have their center of mass above the hips or above the hind leg. So they need some kind of balance point so that they're not basically falling forwards or falling backwards. And if you're a quadruped, you're really not worried about that. And in fact, you probably want your center of mass, and this is basically an average point of all of your weight, to sit probably in front of your hips. For things like this, where they've got bigger hind legs than forelegs, it won't that center of mass won't be exactly between the two. It will be closer to the back legs than the forelegs, but what it won't be is directly over the feet, which is what you need for balance. And we can do this because we've got good skeletons. We have a pretty good idea of where their muscles go. We have a pretty good idea of things like lungs, which is obviously actually a fairly big space in the chest, which weighs almost nothing. And we can work out where all those bits go from their different weights and different densities and how much of them there are, and get a computer to calculate the center of mass. And that's one way we can do it. And in the case of things like Triceratops, it's very clear that its center of mass is well in front of its hind legs, and also well behind its forelegs. So it would really struggle to balance unless it, reared up very, very high and was standing almost vertical. And
then it might overbalance the wrong way.
It's probably not a very normal posture. And also it would make all kinds of weird suboptimal angles for muscle function. You'd be stretching certain muscles to an absolute extreme to be able to do that, which means they stop functioning more or less.
Is the Triceratops a typical Ceratopsian? Is it like, have similar Ceratopsians to the Triceratops been around, or is there anything uniquely special? Is the three horns thing uniquely special?
The three horns thing is sort of special, actually. I think we've mentioned this before already, just a couple of episodes in. So many of the most iconic dinosaurs that people would most recognise by name or sight are kind of weird. They're almost anomalous examples of the group, and Triceratops is another one like this. In some ways, it's a very typical derived ceratopsian. Okay, ignoring the early ones, which are bipeds, and the ones which basically had no frill and no horns. Yeah, it's pretty basic. It's a big animal, though it is the biggest, which already makes it a little unique. Once you get into these later ceratopsians in the Cretaceous, there are basically two major groups, and there are those like Triceratops who have big horns over the eyes and a little horn over the nose, and those that have a big horn over the nose and little horns over the eyes.
Oh, no, none with all three.
So there's one found just a few years ago in Canada called Rigali Ceratops, the Royal Ceratopsian, which was named because it's housed at the Royal Tyrrell Museum in Drumheller in Alberta, Canada, and it was their 50th anniversary, I think it was, that they named this thing, and obviously it has a royal seal, and therefore they thought it quite neat to kind of link to that side of the museum. And it does have it has a really cool frill as well, so they call it its little crown. Rigali Ceratops is really weird because its nose horn is a little bit bigger than its brow horns, even though it's an extremely close relative of Triceratops. So it's a bit of an oddity where it's kind of done the wrong thing, and it's gone for a big nose horn and little brow horns, whilst being part of the group that have a little nose horn and big brow horns.
Okay.
There's a lovely thing called Pachyrhinosaurus, the thick-nosed lizard, and rather than having a big horn on its nose, it basically has just a giant lump of bone. It's got this giant boss, basically. So it hasn't so much gone for a horn as for a big, flat, battering ram type thing.
Cool. So instead of a sword, it's gone for a hammer.
Yeah. And then the other thing that these guys have is they've all got their frills, and around the edge of the frills are usually a bunch of little spikes. And often, and particularly actually in the long-nosed horned ceratopsians, these are often really quite elaborate. They can be very long and very spiky. They can point in odd directions. They can curl over. They can expand and branch and do all kinds of funny little things. The Triceratops side of things tend to go less in for that generally, and Triceratops itself has just a row of little triangular spikes around the edge. So in that regard, it's got a pretty uninteresting frill. What's really weird about Triceratops, though, is that its frill is solid. It is a single sheet of bone, and all the others have enormous holes in them because these things would have weighed an absolute ton.
That's gonna... Oh, I've got a sore neck just imagining it.
That's the thing. On a big Triceratops, I'm looking at my dining table and I'm thinking, yeah, it's about the size of a dining table. You know, it's 1.5 meters long and 1 meter or so wide, and 1 centimetre or so thick of solid bone. Even on a giant animal, that is an absolute ton of weight to hold up with your neck when you've already got the rest of the skull and its horns and muscles and the bone and everything else. It really shouldn't be a surprise that all the other ceratopsians turn this thing into basically an outline. It's like a giant M shape with two huge holes in the middle. It's really strange that Triceratops would completely reverse that and turn it into this solid sheet of really heavy bone. And its other weird thing is still not known properly. So it's one of these frustrating things in paleontology where someone has said something, an actual paleontologist rather than just some random comment on the internet, and then not really provide much evidence for it. So there is an abstract from a scientific conference, so it's just a little paragraph of text, and there was a talk about this, but of course, if you didn't go to that talk, as I didn't, then all you've got is a little paragraph of text to go on. And there's a specimen of Triceratops I think it's in Texas. It's not from Texas, but it's in Texas, and it's got loads of skin, and it pointed to these really big scales, like palm of your hand size scales along the back. Whereas the others are little, fairly boring reptile scales. This rises up into a big point and is described as kind of being nipple-like.
Okay.
And they suggest that the tip of these are broken off and that they would have continued and been even longer.
So like a porcupine?
Well, so this is the thing. We talked last time out about weird ornithischians that have some filamentous-like things which may or may not be feathers. One of those guys that we mentioned is actually one of these little early pseudo-bipedal ceratopsians. So the ceratopsians are one of the groups that may have had some kind of filaments, or at least one definitely did, some of the others might. And therefore it suggested, is this the base of a big filament on the back of Triceratops?
It might not just be a spike, it could be a feather.
Or a filament of some description like that, yeah. Now, these are fairly few and far between. You know, you've got these big palm-sized scales and then a big ring of 2 or 3 layers of other scales and then another one. So it's not like you're going to get any kind of coating from this. But yeah, the idea is that the back and sides of Triceratops may have had these, well, did have these huge scales, but may have had little kind of plumes coming off them, and it may have been slightly fluttery and feathery of some description.
How fabulous. How fabulous. Yeah. That would have looked amazing. Or really like armoured and spiky and horrible and claw-like
And that's the frustrating thing. I've seen like one photo of these scales and there's been no formal scientific paper really working this idea up and doing comparisons and giving a detailed description and all the other stuff that you'd want. So it remains kind of pretty plausible from what's been said, but you'd want a real proper scientific study. But it doesn't, you are now seeing illustrations online which are taking this and running with it and combining certain kinds of combinations of plumes and filaments on Triceratops and on others. Because again, it's not like we have tons of really good skin for all the other ceratopsians, but obviously this is a pretty definitive one where you can go, well, Triceratops at least had these big pointy scales, and they clearly got something a bit weird going on.
I mean, what did it eat? Because, I'm presuming it was a herbivore, wasn't it?
Yeah, so other than a couple of the earliest ornithischians, which we think are probably kind of badgery and eat just about anything.
I was thinking, this entire time when you've been saying it's got big, its bum in the air, and it's got, quite a short, like, little front legs, and it's quite, I imagine it being quite badger-like in its sort of, like, bulkiness.
In its bulkiness, yes, but obviously a lot bigger than your average badger.
Not bigger. It depends how close you get to them. You can make a badger seem very big if you sort of lie on the ground.
If you stand very close, yeah. Things tend to look bigger when you get closer to them. It's an odd phenomenon. Triceratops, indeed, pretty much all the ornithischians were fully herbivorous. It's got a big beak at the front and really quite sharp beak, and then behind that a really good row of teeth with little ridges on them, which are really good for grinding up plant matter. So as we kind of talked about with Diplodocus, when you get to this kind of size, you actually turn into a really quite efficient digester. And so they're probably fairly efficient animals.
So when you say beak, you mean just like a bird beak, or like a squid beak, or we just literally mean like a beak?
Everyone associates beaks with birds, which is entirely reasonable, of course, but beaks have evolved in loads and loads and loads of different animals, and in particular in loads and loads of different reptiles. In fact, if you think about it for just a minute, turtles, tortoises and terrapins all have beaks. So actually, beaks aren't just a birdie thing. There's a whole group of reptiles right there that have them too. And the platypus, okay, that's something a bit different, but duckbill platypus have something that's
squid.
Pretty equivalent. Squids do, though again, they're doing something in a slightly different way, of course. All a beak really is a bony part of the front of the face that's covered in keratin, the stuff that makes up our skin and our fingernails and our hair and indeed feathers. And that's all it really is. But beaks evolved independently in reptiles like 10 or 15 times. They turn up again and again and again. They turn up half a dozen different times in dinosaurs with independent groups. The birds are just one of like 5 theropod groups which decided to get a beak and get rid of their teeth.
So it's a bit like eyes, and eyes evolve differently in different things.
Yeah, eyes have evolved again and again and again. I mean, it's a fairly simple thing to do, actually, in the grand scheme of things, because all you've really got to do is add more keratin to the front of your face, and you're already... but you've already got the genes for doing that to make the skin and to make the hair and to make your nails. It's virtually just a claw on your mouth rather than on your finger. And so it's not like you don't have the proteins and the instructions to do that. It's just a question of doing it in the right spot at the right time. So it's perhaps not a big surprise that so many animals have been able to do this at one time or another.
Maybe we're just missing out on this as as a human species. Is obviously this is sexual selection, and beaks are just sexy to some animals. That's what it is. A good beak must be a very attractive thing to a lot of animals.
If you're a toucan, absolutely you're a hornbill.
Oh, they're amazing. The really weird thing about toucans is how light their beak is and how hollow it is and how that clacky noise it makes. It's so bizarre.
Yeah, toucan beaks are
freaky.
Basically air with a bit of with a bit of keratin on top of them.
They look fabulous.
Yeah, oh, they do. I worked at Bristol Zoo briefly, and one of the things I did was look after the toucans, and up close, like 2 inches away, when you're feeding them a couple of grapes and you can see them in sunlight, they are even more beautiful and even more stunning than you imagine.
See, they are attractive then. That's what you're saying. Beaks are sexy. This is why they've been selected for.
I'll investigate more fully. But returning to Triceratops, big beak at the front, really quite common. Ornithischians, I'm tempted to say all. Yeah, I think all ornithischians have a beak at the front, and then teeth behind. And Triceratops teeth, they're about the size of I'm looking at my thumb, probably the size of my thumbnail or so. So fairly big and kind of slightly diamond shaped with little ridges on them. And that's, they grind against each other and break plant food down. Interestingly, Ceratopsian teeth are very unusual in that they have 2 roots. So like our own teeth, well, we have
3,
2 or kind of 3, depending. But most reptiles have a single one. So you've got the crown and then the root, and that's it. It's just a simple, it's almost like a stick, basically, with some complexity to it. But the Ceratopsian teeth, as you get down to the root, they branch forward and back. And so they form this nice little kind of Y shape. And that's completely unique. We don't see it in any other reptile group. And that's one of those little things which is really useful, because it means when you find something like that, you know what you've got. And that actually, we're drifting off topic massively here, but it's a really interesting thing. So Ceratopsians are really common in North America, and they're really common in Asia. And of course, actually wind back 50, 60 million years, and that gap between, Alaska and Eastern Russia was even smaller then. So actually crossing that kind of gap was probably pretty trivial. And indeed, we've got lots of evidence of groups going in both directions at various different times. So it's not a big surprise that we've got Ceratopsians in Asia and North America. Getting across to South America, probably pretty tricky. India wasn't around at that point. Africa's kind of a long way away. And again, Africa was mostly separate. But Europe isn't. And lots of things that turn up in Asia and North America also turn up in Europe. Both 65 million years ago was a very different time, and we don't have much rocks then. But going back into the earlier Cretaceous, pretty much everything you find in Europe and North America, everything you find in North America and Asia, you find in Europe, except the Ceratopsians.
What?
For some reason, they didn't seem to make it. And yet, there's a tooth from, I can't remember now if it's Hungary or Romania. I'm going to say Hungary. There is one single, double-rooted, very obviously Ceratopsian tooth from, I'm going to say Hungary. So it looks like they were around, but then for some reason they're either super rare or we're just not finding them. And we really don't know why, because everything else made it here and everything else is here, and why aren't they?
We didn't get T-Rex here, did we?
No, we don't, but we have several Tyrannosaurs. In fact, we have 2 in the UK, a thing called Proceratosaurus and a thing called Eotyrannus, both British. One from the Isle of Wight, and I can't remember where the other one's from. But we, that's the thing. We have Tyrannosaurs in Europe. We have duck-billed dinosaurs in Europe. We have some of the Asian sauropods get into Europe. We have things. There's a weird, I want to do an episode on these one day, this tiny group of weird lot dinosaurs called the Alvarezsaurs, which at one time or another were mistaken for just about everything, including owls at one point. And we have Alvarezsaurs in Europe, and they shuttle between North America and Asia like nobody's business. Like, if you look at the biogeography of the group, they go to North America and split, and then they go back into Asia, and they go back into North America again. And they're in Europe, and yet no Ceratopsians, or at least a tooth and a couple of bone fragments, and that's it.
That's bizarre.
Really, really weird. And I don't know this subject well at all, but I'm not aware of anyone having even come up with a reasonable speculation for why basically every other group made it and these guys didn't. Or worse, they did, and yet we just can't find them anywhere.
Maybe they just got eaten whole.
That, of course, is what happens to most animals, which is why the fossil record is so sparse. Yeah, Ceratopsians in Europe. there's a study to do on one tooth. You might run out quick.
That sounds like a live album from the 1970s, the Ceratopsians in Europe. Well, I joke about them being eaten, but I mean, presumably, obviously it's in every film that the T-Rex predates the Ceratops. And presumably that's what the horns and frill was for as defence.
We're immediately getting once again into a really more complicated subject than people have made it sound before. Yeah, I know. It's
fine.
Yes, it's almost like not everything in biology is really simple and obvious. So we'll start with the horns, because in some ways they are a bit easier. So it would be a great surprise, for whatever reason that horns may have evolved. If you're a Triceratops sitting around with these giant horns and a T-Rex turns up and you can't run away, it would be very odd indeed if you didn't use them to try and fight one off. But of course, that's not necessarily the same as that's what they were for. That was the evolutionary origin. Now, we think this happened, and as usual, there's one extraordinary specimen that was described in 2008. And that number I do know because I happened to looking it up just the other day for something else. And it's a Triceratops horn. It's a single broken brow horn, but it has a bunch of scrapes up the sides of it, which can really only have been made by a couple of Tyrannosaur teeth.
Wow.
And it would be very odd indeed if a T-Rex decided to try and eat dead horn, because there's nothing to eat there whatsoever. And while you have to remember that is a possibility, the interpretation, and I think it's reasonable, is that this was some kind of combat and a Tyrannosaur ended up in a face-off with a Triceratops and ended up biting on the horn. So there,
unless the T-Rex is asleep, okay, with his mouth open, and the Triceratops went over, or the T-Rex maybe was tired and yawning, and the Triceratops popped his horn in there, in the way you do. I don't know if you do that with your friends, you put your finger in their mouth.
Yeah,
don't do that.
I do, and they hate it.
Exactly. Maybe that's what happened, but the Triceratops wasn't quick enough to back out and
got bitten. Yeah.
Exactly. That's more likely, I think.
There's another hypothesis to consider there. Now, going back to the kind of T-Rex story, because we didn't even really cover this when we did T-Rex, there's really good evidence to suggest that most carnivorous dinosaurs are predominantly preying on juveniles for various reasons. That there's more of them, they're much less dangerous, and they're naive, and they do stupid things. And again, it makes sense. A big Triceratops is 7-8 plus tons with horns 2 meters long. Do you really want to go after one of them every time you get hungry? It's not a good look for a predator. You're very likely to get injured, and if you get injured as a predator, you're basically doomed. So it's not that it didn't happen, but the idea that Triceratops needed its horns to just face off with carnivores, and particularly T-Rex, almost certainly isn't true. So you want to look for another reason. And the obvious reason is that mostly what they're fighting is other Triceratops. That's the main reason that various antelope and deer and things like this have horns and stuff. And you can do studies like this. So a friend of mine, Andy Farkey, who's based in California in the States, did a really cool study where he basically got hold of, what he got is he bought a couple of little toy Triceratops.
Really? And did he run them at each other? Did he?
Pretty much. Science. Little skulls. Just like the Gary Larson cartoon of, hey, you guys get back to work. But what he did is he used them to work out, if two Triceratops went head to head, where are their horns going to end up? What angles and what kind of positions are they going to get in? So he used that to work out what it might look like if they interlocked and kind of wrestled like so many antelope and deer and sheep do. Then he marked out where those areas were that the horns would hit. Then he went and looked at every single Triceratops skull that he could and looked for evidence of the bones getting bashed up and healing. And lo and behold, what you actually find is the areas that he'd laid down as being the ones where it looked like they would hit each other are the areas that have by far and away the most chips and bashes and gouges that have healed up. So it's a really good evidence that they were doing exactly that. And as a lovely counterpoint, he looked at one of the groups of Ceratopsians with the long nose horns, which if they are fighting would not be locking together because obviously you can't lock one thing on one. And those don't tend to have damage in those areas. So it's not just, Ceratopsians get injured there. It's no, Triceratops gets injured there. So that's really good evidence that these guys are coming together and actually fighting each other.
But once again made because he bought 2 children's toys, dipped their horns in ink, and then locked them up and went, rah, and charged, and then went, oh, look, where are they inky? That's...
My field of study is a deeply serious and professional one, and how dare you impugn the quality of the research of myself and my friends and colleagues as we get to go rah with little toy dinosaurs.
The question I want to ask is, does this mean if they were fighting all the time that they lived in groups and fought constantly, or is it like, are they more like, are they buffalo, or are they, and there's herds of them, they all bash each other up only during a rut and that sort of thing, or have they got these weapons because they're solitary and they need to defend their territory against other Triceratops?
So for some Ceratopsians, we absolutely have really good evidence of them living in groups because we have giant mass assemblages of them. Hundreds of individuals, even thousands of individuals dying together. Probably as a result of them getting drowned in river crossings and mass floods and stuff like this.
That's sad.
Much like what you see in the Attenborough documentaries of here's a million wildebeest crossing the river and loads of them drown. Something fairly similar. That alone actually doesn't necessarily mean they live in groups, because actually wildebeest mostly like living in small family groups, but obviously the migration forces them into this giant herd, which they're not normally part of. But we see this for loads of different Ceratopsians at loads of different times. They're not just these one-off events. They semi-regularly get trapped in groups, which gives us a pretty good indicator that they must have been hanging around in groups quite often for us to keep finding them. Triceratops is a bit of an exception. We've got loads and loads and loads and loads of specimens of Triceratops. They're really common, and yet one thing we don't find is groups of them, even though they've got, in some ways, a better fossil record than many others. So that initially made them look basically solitary, as ever with a couple of buts. So first of all, we've got definitely one, but I think 2 groups of Triceratops, but they're all young ones. And that therefore, and young Triceratops are almost non-existent. So that suggests that, hang on, we almost never find them, and when we do, they're in groups. So maybe that looks like they're living in groups when they're young, and then as they grow up, they separate and go their separate ways. You see this with some things like deer. Young males are too young and not big enough to defend a territory, but they're also vulnerable to predators. So living in a group with a bunch of other random males is probably a good idea, because it saves you getting beaten up and eaten so often, and you're not yet ready to be on your own. So they could be doing something like that. There is, again, on like the paleontology grapevine, I'm not giving away any big secret that this has been talked about a while.
No, don't underplay it. No, this is a massive secret.
Okay. Yes. It's a massive secret that there's...
You heard it here first.
Yes, there is supposed to be a group of, I don't know if it's adult or mixed ages, so juveniles and adults, but there is supposedly a group including adult Triceratops that's now been discovered but hasn't been described yet. Whether or not that changes things, because again, that would still be one example, and we still have loads of solitary ones when we wouldn't necessarily expect that. My personal suspicion is that Triceratops is still a bit of an oddity, and they are probably rather more solitary than your average Ceratopsian was. But yeah, that leads and yeah, these injuries are really common from the combat. Now, if these were, purely kind of mating competition, first of all, we'd expect males to have much bigger or different horns to females, and that doesn't appear to be the case. And then all of them are injured. So that implies at least the possibility that this is much more about stuff like, territory control, water, resources control, and anyone will fight anyone depending on the situation, which is why everyone ends up bashed up.
So now they remind me of grizzly bears, where they do come together occasionally, but really they're solitary. And
in the right circumstances.
Girls fight boys, and boys fight girls, and boys fight boys, and girls fight girls.
Grizzlies I use grizzlies all the time because they're such a good example of why we've got to be so careful interpreting groups in dinosaurs. Because, there's a photo from the US Fish and Wildlife Service of something like 50 grizzlies in an area about the size of an acre, because there's a massive salmon run going on, and there's just more food than anyone knows what to do with, and they're all just standing around eating dead salmon. Normally, grizzlies wouldn't be within miles of each other and are, extremely aggressive to one another. But you've got all these grizzlies standing around in waist-deep water, and I look at that and go, if a flash flood came down this valley now and buried them all. I can guarantee that 500,000 years later, future paleontologists would go, grizzly bears lived in these awesome giant packs of 50 animals at a time, because that's what they found, a group of 50 of them buried together.
Yeah.
And so you've got to be really careful with this kind of behavioural stuff. And the flip side, of course, is that even if you live in groups, it's very rare that everyone dies together simultaneously and gets buried simultaneously. So just because you find them in a group doesn't mean they live in a group, and just because you find them on their own doesn't mean they live on their own.
But you were saying earlier you don't find many juveniles.
Yeah, well, juveniles in general in the fossil record are super rare because they're more likely to be eaten. And again, if you get eaten by something like a T-Rex, not a lot comes out the other end. Whereas if a T-Rex is eating an adult Triceratops that weighs 5 or 6 tons, they're not going to be able to eat it all before it goes rotten. And they're not going to chew up and destroy every single bone. And they're not going to bother chewing on things like horns. So actually, it does make sense that juveniles will tend to be destroyed rather more readily than adults will. So even though juveniles are probably much more numerous, lots of eggs, lots of babies, they also tend to get trashed a lot more easily. But as I say, in the case of Triceratops, it's pretty leading that juveniles are almost unknown, but whenever you find them, there's a group together. Adults are really common, but whenever you find them, they're on their own. That does, again, individual cases, you've always got to be a bit, but when you look at that whole range of finds, there does seem to be a pattern. Yeah. So I suspect on average that's what they're doing. And this also fits, again, going back to the horns, this fits with the growth pattern. Babies still have horns and still have frills, but they're tiny. We know juveniles are really vulnerable to predation. If horns were critical to fighting off predators, the babies need horns way more than the adults do. And they don't have them. They're tiny and they grow very rapidly just about the time that these adults start getting much bigger physically. And this is a thing called positive allometry. And so this is where something is growing faster than everything else. And allometry is totally normal. Baby humans have giant heads and little arms and legs, and they grow into them. So the arms and legs have positive allometry because they get bigger, and the heads have negative allometry because they get smaller.
They don't get smaller, they stay the same size. Don't confuse our audience.
Okay, obviously, proportionally, and it depends what thing you're scaling against what other thing as to quite what relationship you get. But, a classic thing with features used for sexual competition or social competition have really strong positive allometry. Again, we see that. You can go and, go past a field of cows, and bullocks that are like 2/3, 3/4 grown still have little horns. And they're only going to get like 10% bigger, but their horns are going to get 200% bigger or 500% bigger. So there's this very rapid burst of growth just as they hit full size, and they need to start swaggering around and being bullish, strangely enough. And Triceratops shows the exact same pattern in the growth of the horns and the growth of the frill. And so that really suggests that it's something much more about signaling and dominating and engaging with other Triceratops than it is about fighting off T-Rex.
This seems to be like incredibly violent animal that it's just defending itself against itself. And I was wondering, cause we've talked a little bit about, what they ate and everything else, but could it be a sign of the harsh, climate, or the fact there wasn't much food, or the fact they needed to be so territorial? Is there anything that you can, anything you could think about that way, why they've evolved this way?
It could just be the local conditions, or something weird that's going on. But again, our understanding of why animals live in groups is pretty incomplete, and we often have weird pictures. So most people's impression of rhinos, for example, is that they stand around on their own or in 2s or 3s. And rhinos do that a lot, but mostly, or at least in part, because there aren't many rhinos anymore. You only need to go back a century and there are reports, and I've seen the odd photo of like 50, 60 rhino together in a big,
my goodness,
herd. And we don't think of rhinos like that because most zoos don't have more than 2 or 3, and even if you go on safari, you don't see more than 2 or 3.
Just the noise they'd make would be hilarious. I don't know if you've heard a rhino before, but it's worth Googling a rhino. What they sound like is not what you expect rhinos to sound like.
They make some wonderfully weird squeaks and squeals, and yeah.
Basically, they're like evil giant guinea pig. It's very
Yes. But the other side of that is, rhinos can be really aggressive to one another. And one of the one of the big, like the mating ritual for rhinos mostly is males charging and beating up the female. And so part of the reason females have horns is to fight off overly aggressive males, as well as for going after things like lions. So you can get these weird conjunctions of features. Yeah, it's really not clear, is this just territory domination? Is this territory domination actually with a fair bit of anti-predator threat? Because even if T-Rex isn't much of a threat, you still want to tell it to sod off, and that's quite useful. Maybe they're fighting each other, even if it's just mating. Again, like male and female tigers fight quite heavily as part of their mating ritual, can really injure each other. Maybe that's just what Triceratops did. We don't really know. But that still leaves the frill. That's the horns kind of dealt with. That still leaves the frill. The frill's growing the same way, which suggests that it's a signal and suggests that it's part of that. And people, again, one of those old arguments, people went, it's armor. It's all anti-predator defense, and so it's got this big shield to cover its neck. Well, first of all, none of the other Ceratopsians did that because their frills were all hollow. Secondly, it doesn't really cover their neck very well. Thirdly, we know, again, we talked about T-Rex bites. T-Rex can bite through bone way thicker than a T-Rex frill, the Triceratops frill. This is not some big sheet of armor which is stopping any big carnivore nailing you. And fourthly, actually, the most vulnerable part of these guys is their back legs, because that's where their huge leg muscles and driving muscles are. A bite there, you'll bleed out very quickly and not be able to run. If you really wanted to protect anything, the back of your neck immediately behind the spikes is probably not the bit they'd go for, and doubly not if you were running away. So it covers the wrong bit not very well and wouldn't be much of a defense anyway. Armor is... we can ditch that hypothesis. And the obvious conclusion is that, again, it's some kind of signal. Again, it's positively allometric. It grows fast just as they get to adult size. And that suggests it's presumably part of some kind of overall big signal ritual thing of basically going, look how big and strong and sexy I am. I can carry this giant thing of bone, and my thing of bone is bigger than yours. Therefore, I'm bigger and tougher than you.
So it's basically, they're peacocks.
Yeah, it's a billboard. But the question is, why make it solid? And that we still don't know, because all the other Ceratopsians don't have it as solid, and it is a lot of extra weight to carry round. You could understand if it evolved solid and it took time for it to get thinner, but it's been running around as this hollow structure for 50 million years, and they go, you know what, we want to make that solid.
Is it something to do with maybe, does it act like an amplifier? So that if the Ceratops made a weird noise, it would amplify round? No,
it's not really, it doesn't really point forwards, so
no.
It's not really dish-shaped.
No.
It's an oddity. I don't, it's not like I've read every scientific paper, but yeah, I don't think anyone's really seriously looked at this and tried to work out quite why they'd have that when others don't.
If we have time, I just want to ask about what's a Torosaurus?
Torosaurus. So Torosaurus, so that's the bull lizard, strange enough. So it's a very close relative of Triceratops. It has a little nose horn and two big brow horns, and it has an even bigger frill, though a hollow one, or an open one. And in fact, Torosaurus is the largest... I think Torosaurus has the record of the largest skull of any terrestrial animal ever.
What?
It's kind of cheating because so much of that is frill. It's not like it just has one enormous head. I think the biggest one is well over 3 meters, and there's an awful lot of that is frill, but dear God, that's a big skull.
But presumably whales have got bigger skulls, but terrestrial,
I said terrestrial, yeah.
You did.
But
I was just thinking, sorry.
even then, it's bigger than most whales. 3 meters is a hell of a head.
Yeah.
Torosaurus, very, very close relative of Triceratops, and so it often comes up in discussions of Triceratops because a couple of people, again, we talked about like the Nanotyrannus T-Rex thing. Similarly, people have suggested that Triceratops basically turns into what we call Torosaurus. In other words, there's only one genus here. We've accidentally named a second species, which would be Torosaurus. Triceratops was discovered first, so the name Triceratops would stay. But that basically, whenever you have a really, really big Triceratops, its frill gets even bigger and opens up, and it changes until it looks like what we have been calling Torosaurus. This has been a whole debate for about 10 years now, 12, give or take.
It's like a grasshopper turning into a locust.
Yeah, pretty much. And there are versions of this out there. You do get animals which, once they get really big, can change quite dramatically, relatively late in growth, even when they're already adults. So there is precedent for this. But I think it's fair to say that the evidence that's been presented for this is pretty weak, and there are very few researchers who agree with this hypothesis. And the main problem is that Triceratops is really, really common, and Torosaurus is really quite rare. Now, if it's a very rare, only the very biggest males or only the very biggest individuals do this, you might expect Torosaurus to be rare. But for a start, there's 2 or 3 places where we found Torosaurus, and we've never found Triceratops. Wow. So if it's this super rare version, how come we keep finding the rare version and can't find the common normal version? That's not a great look for this idea. And yeah, there are some Torosaurus which aren't that big. They're smaller than the biggest Triceratops, which again, therefore, okay, maybe that's a smaller population. Maybe they're a couple of million years earlier, but again, it doesn't look great. The one thing which is really in its favor is apparently if you look at the structure of the bone of the frill of Triceratops, in the middle, the bits we'd normally expect to have holes in, they are undergoing changes and becoming thinner and thinner and thinner. And that would suggest that if they keep going, they will open up and turn into holes. That's really intriguing and really leading, but that's not the same thing and therefore Torosaurus is the way to go. The other one is those little spikes we mentioned, the little spikes that run around the margin of the frill. They're different numbers in all the different Ceratopsian species, and they're different numbers between Triceratops and Torosaurus. And again, there's variation. Every so often you find an individual which has an odd number, or they have like 23 on one side and 24 on the other side. There's a little bit of, quibbly variation in the same way that some people have like an extra set of wisdom teeth or things like this. But when all Torosaurus have one number and basically all Triceratops have the other number, what's happening to these? Why are, you can imagine, all right, the frill grows suddenly a bit bigger and opens up, but somehow a whole bunch of these grow extra. And which are the extra ones?
Yeah.
Which ones have suddenly moved and new ones have popped up? And why don't you ever find something that's halfway between... Why haven't we found a Triceratops which has not just faded the frill, but actually got a couple of little holes in it? And there's a couple of new little spikes just forming at the edges. Because we got loads of Triceratops. And those things just don't exist. And so when you put that package together, the case that Triceratops might be doing something weird when it gets big, pretty good. The case that means it turns into Torosaurus, and Torosaurus is just a giant weird Triceratops, pretty weak.
I think trying to put this creature together, it's just because the moment you focus on the beak, then you focus on the horns and how the horns are different between different species, and this massive frill, and then you forget, oh no, it's got plumes as well. Trying to picture it all in your head is really difficult. But there are full-time artists who dedicate hours and hours and hours of work to recreating dinosaurs, and not just in graphic design, not just in paint, but also in cake. And down the line, we have the magnificent artist Ralph Attanasia, who I believe has a question for you, Dave. I have a question. Is one thing that, because I'm an artist, and when I'm reconstructing dinosaurs in whatever medium, I wonder about like the fleshy parts of the face, because really mostly all we have is bone. But specifically on like the duck-billed dinosaurs and the Ceratopsians and things like that, I always wonder how much cheek I should be giving them. Do you know what I mean? Like, like behind the back from the beak.
Oh yeah, no, that's a really cool question, and that's one which, it's a minor detail, but it just bounces backwards and forwards between different people at various different times, and I think it's come close to a decent resolution recently. There's a kind of fundamental question here of, I guess, are dinosaur faces more like lizards or more like crocodiles? So crocodiles, don't really have any kind of lips. They don't really have any kind of cheeks. The teeth just stick out and everything's right there. And normally we take crocodiles as our kind of default, because of course birds have beaks, so they're probably not going to tell us much about this kind of thing in dinosaurs. But we also know that crocodiles live in water and ambush things from water, and actually lips and cheeks there would be a huge drag on the mouth, and therefore crocodiles probably got rid of them because they live in water, and therefore it may not give you a big insight into what dinosaurs look like. And so it might be better to look at lizards, even though they're much more distantly related to dinosaurs. And there we see that almost all of them, when they close their mouth, the teeth vanish because they're completely covered by skin. But, you know, there's a trade-off between these different arguments, and that means that various paleontologists at different times have said, you know, not just things like, the duckbills, the hadrosaurs, and other things, and stegosaurs, but even into, you know, things like Tyrannosaurus. They did have lips and the mouths were completely sealed, or they didn't have lips and their teeth just stuck out in the open. With the herbivores, there was maybe a better case for this, simply on the grounds that if you're eating tons and tons of leaves and chewing them up a lot, you don't want all your food just falling out your mouth constantly. If you're chewing and chewing and chewing and chewing, unlike the carnivores who probably just bit and swallowed.
Right.
So that immediately led to the idea that they had something. But yeah, recently people have started looking at this in more detail. And there's been a couple of really cool papers changing how we've reconstructed some of the muscles around the jawline and around the side of the face. And it increasingly looks like, they probably had some kind of... It's not necessarily kind of a cheek in a mammal sense, and certainly not in like a hamster sense. You know, you can just cram everything in and fill your face up. But yeah, these guys probably had a beak at the front, and then after that it was skin. There was no big open-mouthed jawline, and that a lot of the side of their faces were basically covered up by a combination of skin and muscles to hold everything in the mouth when they chew.
Neat. I have to say, there's something really attractive about the idea of like a cheek pouch stuffing Protoceratops.
I realised once I'd said it, there's lots of paleo artists out there who like drawing speculative stuff because, of course, there's lots of soft tissue that we don't know about. I don't think anyone's ever drawn a dinosaur with cheek pouches. And
you say that now, but Brian Eng has probably heard us talking about this somewhere and done it on his own.
Oh, I think Brian, who is chief among those people who are really pushing the speculative stuff, I suspect his ears are burning now, and he is currently drawing it because
he's woken from a cold sweat.
Yeah, Eng sense tingling, and he's realised that he's never drawn cheek pouch.
But surely, if you look at animals with cheek pouches, like your little hamsters and stuff, right, they've got paws to help them put. So surely you could be able to tell which dinosaurs would have stored food in their cheeks by looking at their sort of paw size, as it were, their front paws. So it's not that one with the big thumb spike, is what I'm saying.
No, not an iguanodon. So, I mean, things like that are often quite good at manipulating stuff. So, your squirrels and your hamsters and stuff like that. But there's enough videos of hamsters just hoovering stuff up and doing it with their tongues. Dinosaurs don't appear to have had very flexible tongues.
How can you tell?
So that's linked to... We actually have bones in the throat called the hyoids. They're present even in humans, though you almost never see them in skeletons in museums or anything like that. And they break quite easily. Apparently that's a really strong indicator of if someone's been strangled, as if they have fractured or broken hyoids. But the hyoids are basically your tongue partly attaches to them. And hyoid bones are present in lots of different things in the fossil record. They're pretty rare because they're small and fragile, but they do turn up. And they give you an idea of what muscles are there and where they anchor, and therefore how much the tongue can move around. So based on the hyoids, it looks like most dinosaurs have a fairly crocodile-like tongue. So they can move it up and down, and they can probably poke it in and out a little bit, but it's nothing like ours that, you can twirl around the mouth. So going back to the cheek pouches, like, if you haven't really got hands and you haven't got a manipulative tongue, how are you going to get stuff in and out?
So, like, every dinosaur book I had as a kid, I'm 35, so I was getting... My books were all from, like,
Lots.
The 80s.
The best time for dinosaur books, let's be honest.
Where did this crazy tongue on Iguanodon come from in all this art? Do you have any idea where that started? Because all my books had Iguanodon reaching out with its tongue and, like, grabbing leaves off of trees and pulling them into its mouth.
Yeah, I have no idea where that came from. Yeah, it's a really common trope. I've seen it a lot. I don't know what the origin of it is. It's probably, you get these kind of... Yeah, well, trope is exactly the right. You know, someone says something once as maybe a speculative idea, and then someone else goes, "Oh, that's cool," and they put it in their book, only it stops becoming a maybe and starts becoming an is or a did, and then the next book goes, "Hey, iguanodons had this, and I saw it written in this book, so it must be true," and then suddenly it's in every book, and quite possibly no scientist ever said it or even suggested it, and even if they did, it was a vague, who knows, maybe type point. But yeah, I don't know the origin of that one.
Talking weird tongues on dinosaurs, in the early cuts of Jurassic Park, they considered having flicky tongues on the velociraptors, like serpents' tongues, so they could sense, smell where the children were.
In the book, T-Rex has a really long tongue, and he reaches in and tries to grab one of the kids. In the book,
they put that scene in The Lost World when he eats the knockoff Bob Barker.
Yeah,
Dr. Burke.
Yeah, they're trapped behind a waterfall, but it reaches in with its tongue, wraps it around one of the kids' legs, and tries to pull them out. And yeah, they couldn't do that, though it's a very cool idea.
But, you do have chameleons and stuff have huge, long, sticky tongues. Are there any evidence of dinosaurs with similar?
No, it was suggested once for a pterosaur, actually, one of the flying reptiles.
That would have been so cool!
Based on the shape of the hyoids. It was actually done by a friend of mine, and I was kind of looked at it and sent him an email and went, "Mate, this looks absolutely nothing like a chameleon tongue." So it was based on the hyoid. He said, "Look, these two hyoids look similar." And it's like, they really don't at all. They're really differently shaped and structured. And chameleons have this really weird... Yeah, very odd hyoids. But yeah, it's the same kind of thing. It's that hyoid shape has a lot to do with tongue length and maneuverability, and the dinosaurs fundamentally don't have hyoids shaped like monitor lizards and snakes and chameleons and things with big, long, flexible tongues.
Well, thank you. That certainly answers that question. That was a much more definitive answer than I was expecting.
Yeah, I was going to say, I answered it at very great length with far more detail than was ever required or desired.
That's what I'm here for.
Welcome to the podcast. Yeah. Yes. Surely, just out of interest, there's nothing... Is there anything to say that maybe dinosaurs has a high fat content, so maybe they didn't have structurally the need for large cheeks, but surely, they might have, needed to have a high body fat to store, energy, and therefore they might have had a chubby cheeked dinosaur.
Now that's possible. If you're at the zoo, next time anyone's at a zoo, go and check out or if you have a pet crocodile, for example, check out the crocodiles. So, okay, they, in some ways they're quite different to dinosaurs, but some zoos, they tend to overfeed their crocs because obviously they don't move around very much and they can get a bit fat. And they get fat in particular in two places. One is at the base of the tail, though that already has a fairly substantial bulge to it because of the musculature, but on overweight animals, it looks disproportionate. And the other one is the back of the jaws. And similarly, crocs already have a huge block of muscle at the back of the jaws because they're biting really hard. But they can lay down fat deposits over it. And so, yeah, you do actually get really fat-cheeked crocodiles on occasion when zoos have overfed them. So I can imagine a Tyrannosaurus getting to the end of the season and maybe it's getting cold and it stopped eating and it's been building up during summer.
And you pinch his little cheeks.
Chubby cheeks.
Yeah, I can imagine you could get a chubby-cheeked T-Rex, which would be pretty awesome.
I've noticed that I actually just coincidentally spent the last 2 days sculpting a Nile crocodile on my own for my own stuff. And there's a lot of... The two things I've noticed is that there's a lot of variation in their faces. They're like as different croc to croc as people are.
Yeah.
Face to from person to person. But yeah, I've seen that big fat chubby jaws and big neck on them.
Yeah, you see it in some of the bigger lizards as well. There's a group called teguins, and yeah, they're Australian, or at least the ones commonly that people keep as exotics. They're really cool pets. As long as you know how to keep a teguin properly, I'm not saying just go and get one. They're specialist animals. But they often get really fat, huge cheeks in exactly the same way. They have a lot of muscle there, but yeah, they can get this big fat layer, and you get this big roll of fat at the back of the head and makes them look super chubby.
You see, I don't see why my Instagram and my Facebook is full of young mums showing chubby-cheeked babies when it could be full of chubby-cheeked crocodiles. Oh!
Much cooler.
That is an Instagram injustice.
Yes.
There's your next thread is,
Yes.
I want to see an Instagram page of fat crocodilians.
It's going to be like that Facebook group for chonky cats.
Ah, yes, chunky crocs. That even's almost
Yeah.
the same. Yes. We should do this.
That's your afternoon taken care of.
Oh, thank you very much, Ralph. Is there anywhere where we can direct our listeners to come and find out more about you and your sculpting ways?
Oh, sure. Actually, anyone who has the Food Network, or I think it might be on Sky in other countries, should check out Buddy vs. Duff, which is a competition that my boss and I are in against another prolific cake maker and his crew. We make a nearly life-sized reconstruction of Zul Cruravastator out of cake, which is pretty badass. And the finale is Star Wars themed, and Billy D. Williams is a guest on it. So that's
wow.
cool. That's not bad.
Yeah.
I think we need to explain, Dave, what Zul is.
So Zul is this wonderful armoured dinosaur from Montana. It's on display in the Royal Ontario Museum in Toronto, and it's one of the most complete armoured dinosaurs in the world. Amazing skull, amazing tail club, and a huge chunk of the body with every individual scale and bit of the bony armour all laid out in original position. So just an absolutely phenomenal and pretty much already iconic new dinosaur find.
Cool. What sort? It's not a Triceratops, though, is it?
No, so this is one of the Ankylosaurs. So these are the armoured dinosaurs, and in particular, it's from the group with the tail clubs that's very close relative to Ankylosaurus. And Zul, I think Ralph says, is named after the Ghostbusters monster because its head looks a bit like.
See, this is what happens when you let people who like dinosaurs name dinosaurs. This is the thing. They should be named by very boring people, and it should be called Specimen B47A. C or something like that. Not it looks like the thing in Ghostbusters. Paleontologists are almost like real people. It's very confusing.
Some of us.
Anyway, if you want to send us pictures of, I believe now we should include Triceratops in the Diplodocus and the T-Rex band. So if you want to send us your drawings or indeed cakes, you can send a cake via email, can't you? We can eat that. Do email us. All of the details are at the end of the show. And that leaves us with nothing to say but... You can't get raw. You always go.
Yeah, all right. I'm sorry, I'm too seductive.
It's a bit Oh no. Okay, never mind.
Leave that one in.
Oh. Thank you for listening to the Terrible Lizards podcast. If you want Terrible Lizards to keep bringing you more information about the world of dinosaurs, then we need to hear from you. Send us your dinosaur drawings and ask us your questions via terriblelizards.co.uk. Email terriblelizardspod@gmail.com. Find us on Patreon, Facebook, and at Izzy_Lawrence and at Dave_Hone on Twitter. Include the hashtag Terrible Lizards. We're hoping to bring you more and more, but we can only do that if we get enough listeners. So please like, share, and subscribe.